Bienvenidos, Ushamdid, and welcome Anne Arundel Community College learners from the CTS-130 Section 402 course during the spring 2021 semester. This is the Cisco Networking Academy Introduction to Networks course, version 7. And in this video tutorial, we're going to be taking a look at a supplemental assignment, which was IP assignment number 1. And in this quiz, you were asked to convert from binary to decimal, from decimal to binary, from decimal to hexadecimal, and now finally our last 10 questions are going to ask us to identify IPv4 address classes. Now, a quick note up front is in modern networks, we're typically not talking about addresses as being Class A, Class B, Class C, because we're typically subnetting a lot of these addresses. However, as a reference point, the classing of the addresses can help to facilitate learning, right? And to kind of build some scaffolding, a foundation for you on which to then step into subnetting and have a better understanding. So let's dive in and take a look at these last 10 questions. And these are the easiest of the 10 questions because when we're talking about identifying the class of an IP, it is the value in the first octet and only the first octet that matters, that will dictate and determine whether or not the address is a Class A address, a Class B address, and again, classified as a Class A, Class B, Class C, Class D. Whoops, that's a terrible D there. Let me pull that back. Class D or Class E, right? Now, the reason that we only look at that first octet is because that's all we need to see in order to determine what the class is. So all of this other stuff here at the end, right? These last 3 octets, we really don't care what's in those last 3 octets because that is not going to change whether or not an address is classified as being Class A, B, C, or D. And so here are the values. Now, this also tends to cause some confusion with the Class A's, and I will explain, and we're going to take a look at an RFC that I have up as well in order to hopefully give you a better understanding of why I'm going to say what I'm about to say. So Class A addresses, the first octet value here would be from 1 all the way up to 126. Now you might be saying, well, wait a second. I've seen references that say it's from 0 to 127. And I've seen other references that say it's from 1 to 127. Why is that? Or you might even see 0 to 126. Now, the reason that you might see these other representations over here is because the confusion around the lowest value that we can have in a Class A address. If we're talking about usable in terms of assignable, not reserved addresses, the values are 1 to 126. Because 0, which would be 0.0.0.0, all the way up to, and here are the values when I talk about 0, right? If we go from 0, 0, 0, 0, all the way up to 0.255, there's that 255 that we talked about, .255, this range of addresses is reserved and not used. Can't be allocated, right? So like you don't have companies that are out there using this range of addresses on the public internet. Not going to happen. And 127 is another range of addresses, and I'll just put 127.0.0.0 up to 127, again, 255, and I'll just put 255 down here, but it means there's 255 in all of the last 3 octets, right? So the same is true here, right? When we talk about local host addressing that you might see. And so again, you could make the argument that 0 and 127 could be included in what we're looking at if you're talking about just simply the value of the first octet. But when we're talking about things in the context of usable, assignable IP addresses that are not sort of special use case, you would say 1 to 126, right? Again, if you were to see something, a question that asked you, what about 0.1.5.9? Okay, well, we can argue whether it's Class A or not, but you would answer Class A. And the same is true of the 127. And then it gets a little bit easier, right? So B would pick right up. It goes to 128. Again, remembering that whole block of 127s is considered private use. So, or not, I don't want to say private use, but reserved use. So then we've got 128 to 191, and that's Class B. And then C is going to be 192, and there's that 192 value that we're very familiar with. And again, take a look at these values. 128, 192. When we get down here, it's going to be 224. When we get down here, it's going to be 240. And those should start ringing some bells in terms of, oh, it's only the first bit in the octet that would be on. 192 would be the first 2 bits. 224 would be the first 3 bits for the network portion. 240 would be the first 4 bits. Those high order bits when we're dealing with an 8-bit octet, right? So these values here should ring some bells. So 192 would go up to 223 for Class C. 224 goes up to 239. Whoops, pen stopped there. 239. And then 240 goes up to 254. And again, you'll notice that I don't have 255 here, right? Because 255, again, is the 127s are looped back, and the 255 is typically when we're talking about some kind of a broadcast IP that we would be working with. So these are the ranges we're going to be dealing with, right? Remember, keep in mind, be sensitive to the fact that you may see 0 to 127. You may see 0 to 126 or 1 to 127. And that's sort of the reason why when we're looking at the Class A space. Now, again, this is easy peasy. So you simply look at the value in the first octet, come over to our trusty chart over here, and you say, okay, well, 100, what range does that fall into? Yep, Class A, because it's inside this range right here. It's between 1 and 126. 220, Class C. 200, Class C. And then I'm going to actually just go ahead and let's get rid of those last 3. And let's just scroll down and we can kind of work through these. So 24, 25, 26, and 27. And I'll leave it kind of like there so that you can see the last 3 octets are scratched out. So 62, that's going to be Class A. And then, what is it? 228, that's going to be Class D. 215 is going to be Class C, and I can't make out what's down there. And so now let's clear the whole screen here, and let's see if we can do the rest of these without the aid of our chart. The last 3, 27, 28, 29, and 30. So here we go. 181. Well, we know that's less than 192, which was where my Class Cs would start, so that would be a B. 24, that's less than 126. We know that's going to be a Class A. 231, that gets a little tricky, right? Because where was that cutoff range? Well, remember, if the first 2 bits are on, that's 192. If the first 3 bits are on for a Class D, it would be what? 128 plus 64 is 192, 224 up to 239. So this would be a Class D. And then 11 is going to be the easiest of all. We know that that's going to be a Class A. Again, this one would be the toughest. And to expand on that, what I'm saying is if the first bit is on, it's 128. 64 makes it 192. That makes it 224. That would make it 240. We're in this range here, right? We're in this range here. And think of it like this. 128 would be a class B. 192 would be a class C. That range would be D. And then 240 and above is going to be E. We don't have A because remember, with A, the first bit value would be 0, right? It would be a 0 here in that bit position value for it to be a class A. All right. So hopefully this was the easiest of the 4 activities we did. And again, with the address classes, it's all about the value in the first octet. That is the value that we're keying on. That is going to trigger the classification of the address either being class A, B, C, D, and again, you've got your class E range, and those are kind of the experimental range. And class D is our multicasting range, that 224, 000 up to 239, 255, 255, 255. That's for multicasting. Remember, we defined multicast, 1 to 1 or more, or 1 or many hosts. That's multicast, that class D. All right, well, that does it for IP assignment number 1. Thanks so much for watching, and let's go on now to IP assignment number 2.